All right, let's continue on with 7.5a. A little review. Little review. Little review. Shh. Quiet, 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 quiet. I ran out of conditioner, so it's all fuzzy. I want to do that. I want my hair like that. I'm going to do that. It does not. I bet you my hair would do that. You have no idea. No. It's not dreads. No, they're not. Is that dreaded? No.
It's basically dreaded. It's not like nicely dreaded.
That is the best. I've been so jealous of his hair for the past 2 years. I want my hair like that. Okay, number 3. We started out by making sure we had the same bases. Let's say I'm going to change this to 2 to the 3rd. That's the same thing as 8. Shh. But I got to keep my exponent there, so I'm going to multiply. Maybe I'll make this a little bigger. And 16. Shh. 16 I'm going to change to 2 to the 4th times 3x plus 4. Then in your brain, you're probably going to say, well, I'll just take the log base 2 of each side. They cancel out, and I get 3 times 5x, 15x. I have to distribute the 4. 4 times 3x is 12x. 4 times 4 is 16. I'm going to subtract 12x from both sides. I get 3x equals 16. Divide by 3, I get x equals 16 thirds. So that was part 1 yesterday. Shh, 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 shh. Okay, number 8. This is where we take the log of both sides, and then we have to actually evaluate it. So we have to come up with a number, and this is where most likely you're going to use change of base formula. Shh, 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 shh. So I'm solving for the x. My goal is to get that x by itself. So I'm going to take I got to get rid of the base 2. So I'm going to take the log base 2 of both sides. So my log base 2 gets rid of that base of the power. I'm left with x plus 3 equals log base 2 25. You could do one or the other. X plus 3. I'm going to do change of base formula first. It's going to be log 25 divided by log of 2. You could also use the natural log. It does It doesn't matter if you use the common log or the natural log. It's going to come out the same. Okay? And then eventually I'm going to minus 3 from both sides. So get your calculator's. Ooh, that's really zoom. Okay, I'm going to take log 25, close the parenthesis, divided by log 2, close the parenthesis. Dakota here? Yeah. You're supposed to go somewhere. Oh, you're supposed to leave now. Hit enter. I get x plus 3. No. Equals 4.644. And then subtract 3 from both sides. I get x equals 1.644. Okay? So when you have to evaluate and it says round the answers to the nearest thousands or 100,000s or whatever, chances are you're going to have to use change of base formula. Change of base formula? Change of base formula? Change of base formula, like on your notes. Okay. This is on your note sheet. 7.4. Okay. All right, let's go on. Yeah, no, that's not cool. Then we did the Ethiopian. Let's do another one. Let's do 12. Okay, I got to subtract. My ultimate goal is to get to that x. Okay, there's a lot of things we have to do before we get to that x. First of all, I'm going to subtract 10 from both sides. Shh. Language, quiet. 3 times 1.5 to the x equals 270. Still trying to get to that x. I'm going to divide by that 3. It's almost acting like a coefficient. 3. So I get 1.5 raised to the x. Shh. Equals 90. Now, there's nothing more I can do. I know the x is an exponent. I'm going to have to use one of my properties, my power property. Okay? So here, I'm just going to use the ln of ln, the natural log. You can use common log. I'm just going to be a little different, use ln. So I'm going to take the ln of both sides. Now remember, I know. God, this is so annoying, guys. If you not, I'm going to really have to like send you outside the classroom to keep it up. The logarithm undoes the exponents. Exponents undoes logarithms. Okay. So whenever you want to get rid of an exponential form, take the log of it. So I have the ln of 1.5 to the x equals the ln of 90. The reason I do that is because I do have an ln key on my calculator. All right, now I'm going to use that property where the power property, where I can take my power and move it to the front of my log. So I get x ln of 1.5 equals the ln of 90. Then I'm going to divide both sides by the ln of 1.5. My ln's cancel. I finally get my x by itself. All you have to do here is, in your calculator, take the ln of 90, close the parenthesis, divide it by the ln of 1.5. I get 11 we'll just say 11.1. So x is going to equal 11.1. That's a pretty involved problem. Okay. Questions? This is not easy stuff. Yeah, you're just going to take, this as e, so I don't have a choice of common log or natural log. I have to use natural log. Okay. So I want to get rid of this exponential form. I want to be able to bring that back out. So I'm going to take the ln of both sides. So I get the ln of e raised to the x plus 5 equals the ln of 25, 125. Now you can think of this as two different ways. The ln is going to cancel out. Remember, logs cancel out the bases. So you can think of it that way, or you can think of it as bringing that x plus 5 out in front. Either way, on the left-hand side, you're going to end up with x plus 5. The ln of 125, well, let's get a estimate here. ln 125, 4.83. Now all I have to do is just minus 5 from both sides. So x is going to equal negative 0.17, I don't know, 2. Round it off. And very complicated, very detailed, but not that hard if you listen and do the practice work. Pardon me? But you guys were preventing other students from learning. All right, flip it over. These I did on your homework sheet yesterday, the back. I kind of went over it on your homework. Let's do a couple of example problems and hopefully it'll clear things up a little bit more. Now, they give us another equation here, another formula. If the log base b of x equals log base b of y, if and only if x equals y. It's just common sense. It really means if x equals y, then you're going to have the same values for the logs. Okay. I have a log base 3 of 5x minus 1, log base 3 of x plus 2. I have the same logs on both sides. Cancel them out. Okay. I have 5x minus 1 equals x plus 7. Subtract x from both sides. 4x minus 1 equals 7. Add 1 to both sides. So x equals 2. Pretty easy. Two is the same thing. Let's look at 3. I have log base 8 of x squared and log base 8 of 16. Again, the logs are going to cancel out. So I get x squared equals 16. Now what? Square root both sides. So what does x equal? Nope. What does x equal? No, it's not just 4. Shh. Nope, not 4i. Plus or minus 4. Okay? That plus or minus, remember, when you're taking a square root of an equation, you have to have that plus or minus. Don't forget that. SATs, which are coming up in a few weeks here, they're going to put both answers on. In fact, they'll probably put 4 in the first choice to try to get you guys to mark it. Yep. Oh, is that right? Oh. Yeah. I'm going to print off some practice exams for you guys. Yeah, whenever you take the square root of a negative number, you're going to end up with I. That's what you have to remember. Yeah. Yeah, we didn't hit that up, and I think we took it out of our curriculum. I don't know why. I'll have to check on that. I'm going to give you some practice tests. We'll do them in class. Abruzzo's class is already has already done some practice tests. So. What? We will. They word math problems different than what you guys are used to.
Yeah, the math problems, they're harder. The word problems are difficult. You don't know what they want.
Yeah. Okay. Part 5. This is where I told you guys yesterday that you have to exponentiate these. In other words, we're going to get rid of the logs this time. You know, on the other side, we're getting rid of the bases by taking the log of those. This time, we're getting rid of the logs by making it an exponent, exponentiated. Okay, so the first one, number 6, the log base 5. So actually, what I'm going to do is make this an exponent and put a 5 on both sides. So this is called exponentiating. This is actually my entire exponent. Okay. Now, my 5 is going to cancel out the log base 5 because exponents cancel out logs. I'm left with 3x plus 1. Now, this is 5 squared. What's 5 squared? 25. Now I have a pretty simple two-step problem. 3x equals 24, so x equals 8. See how that works? Are you interested? Of course we are. 12 ln of x. The first thing I have to do here is I have to make this first number here has to be my log. So I'm going to put that 12 as an exponent of the x. So I get ln of x to the 12 equals 44. Now, don't forget this is base e. Natural log has a base e. So I'm going to exponentiate it with e. E. Okay? That way my e is going to cancel out the natural log, and I'm left with x to the 12 equals, oh shoot, I should have divided by 12 first. Ah, darn it. Makes my life easier. You know what? Let's do it this way. Let's divide by 12 first. Sorry. We could do it the other way. It's just a lot more complicated. So I'm going to cancel out my 12s. I get the ln of x equals 44 divided by 12. 3. 3.67. Okay. Now I'm going to make it exponentiate it using e. So e cancels out ln. I get my x. Now, you have an e raised to a number key. So hit the second button and natural log key. See how my natural log key, I have e to the x. Hit that, and it brings it up on my calculator. And I need to put in 3.67. 3.67. And I get 39.25. It says 1,000, so I got to go one more. 2. Okay? See how these are getting long and complicated? All right, number 9. I have log base 4, so I'm going to be taking these exponentiating using 4 as my base. 4 cancels out log 4. I'm left with 5x minus 6. What's 4 cubed? 4 cubed. 4 cubed. That's right, 64. Add 6 to both sides. 5x equals 70. Divide by 5. let's see, 114. No. Okay, now, one thing we didn't do yesterday is condensing first and then solving. Okay, watch what happens when we condense and solve. I have plus, so this number and this number are going to be multiplied. Product property. Shh. So I have log of 5x times x minus 1 equal 2. Shh. 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 Okay, I'm going to distribute. Let's get rid of the log first. So this is common log. I'm going to exponentiate it with 10 because there's a 10 base 10 there, right? So these cancel out. I'm going to go ahead and distribute it at the same time. 5x times x, 5x squared. 5x times minus 1 is minus 5x. 10 squared is 100. Look what we have. We have a quadratic. I'm going to subtract 100. Now I have to factor and solve. Isn't this fun? First thing I'm going to do is take a 5 out of each term, and I'm left with x squared minus x minus 20 equals 0. Keep going. I have to factor this. So I have an x, a minus 5, and a plus 4, because you guys are experts at factoring, right? So my solutions are what? What does x equal? Set each one of these equal to 0. Negative 4, comma 5. Now, bless you. Here's the thing. Whenever you get more than the power of 1, you have to check your answers. So, negative 4, let's check negative 4. I get the log of 5 times negative 4. Well, right off the bat, I know this isn't going to work because think about the log function, the graph. It can never equal a negative number. Okay, so I know negative 4 is not going to work. Let's see, log 5, plug in 5, I get 25 plus, so I get the log of 25 plus the log of 4. Does that equal 2? And I believe it does. Log 5, I'm sorry, 25 plus log 4, and it equals 2. It checks. So, x equals 5 is a valid solution. Isn't that fun? Should we do another one? Want to do a natural log, number 14? Number 15 is actually kind of icky too. Okay, let's see. I have addition, so I'm going to use the product property. I'm going to take the natural log of x times x plus 3 equal 1. I'm going to exponentiate using e. E cancels out the natural log. I'm going to go ahead and distribute. I get x squared plus 3x, e to the first. Let's see, I think it's, I can't remember what it was. 2.72. Wow, this is really icky. You guys don't know how to factor that. Oh, yeah, you do. You can use the quadratic formula. I think I'm going to stop at this point. I will never